Ladies and gentlemen, it gives me pleasure to welcome all of you at this conference, and I would like to use this opportunity to thank the company Rakurs for allowing us to speak during this panel, although this is not within the theme of this panel, but still photogrammetry is an overarching theme, and surveying has always been a relevant one for all of us. Now I will switch to Spanish, and I suggest that you put on your earphones because I represent here a Mexican company, Sistemas, Avanzados y Proyectos. Ladies and gentlemen, I'm happy to make a presentation on behalf of my company here, and on behalf of Sistemas, Avanzados y Proyectos, I thank the Rakurs company for providing this unique opportunity to participate in this conference. Now, I'm going to present to you a very relevant subject for all of us and for the times that we live in, and I hope that it will be useful for many people here. And this experience can be used in many important projects. I would like to tell you about our experience in this quite advanced technology. It is an in-house technology. We developed a number of sensors and methods. Now I'm talking about scanning, Lidar scanning, and photogrammetry. We have a digital camera. This is quite a specific topic, and we're not using shutter camera, and I hope that you're not too tired to hear what I have to tell you. To begin with, I would like to tell you a bit about our company. Our office is located in the capital city, in Mexico City, and our hangar is in Mexico State, Addis Ababa, where we have the fleet of all our UAVs, all our planes. We are a Mexican company. We have a more than 20-year experience in terms of geomatics. Our company was established in 1972. And now a few words about the background and the achievements of our company throughout the course of its existence. Our company developed and created first orthophotos here in Mexico and Anzalucan, and this is a Mexico State. We did it in 1995. As early as in 1997, same company built the first and established the first station here in Mexico. The name of the company was Virtuoso. And in 1999, we introduced first photogrammetric scanner for this slide film and negative film. We bought and established the first camera from Geosystem. It is a Ukrainian company, and we implemented this technology along with the primary German system. Going on with our background history, our company bought and established the first Lidar by Regal, an Austrian company. And ever since then, we had this idea before, actually, on how to implement and how to facilitate topography imaging. We already had a Lidar and camera. Now, what else could we optimize and achieve not to have double flights and not to process too much of information. So in this way, in 2012, actually the idea was born earlier than that, and now I'm talking about the very first combined system of LiDAR and the digital camera. And naturally, besides, we were also using GPS for more precise data. It happened in 2012, not that long ago. And now we exercise combined LiDAR and camera flights, and I will tell you why. Because now we are using sensor camera. There is not 2 or 3 sensors, only one sensor there. We have no direct stereoscopic function. That is why we had a need to manufacture or fashion a synthetic stereoscope, and that's what we do now for photogrammetric needs. We introduced it in 2013 along with our in-house method to simplify and optimize the process. And in this way, we reached 2015 now, and this year we did the first big project. And I'd like to tell you that for the Mexican history, it was a very important governmental project. Not only do we offer our services on topographic acquisition, but also additional services, which include LiDAR, combined LiDAR and camera acquisition. We have many data, but what can we do with those data? We additionally study new formats, maps, and land use. We also develop geological maps and different deformations and change detection, and all sorts of archaeological projects are under our belt. Now we have quite a sprawling infrastructure as far as informatics is concerned. We have 2 servers, and second one I don't see here, 23 terabytes, which helps us do a parallel computing, which is much faster. Parallel computing of the data we receive from the LiDAR and camera, because these cameras have quite heavy files compared to regular cameras. We can continue now and tell you about the infrastructure of our company. Now, our fleet, the planes that we have, include 2 Cessna 206 that we used for photogrammetric projects. And now they're fully customized for this type of projects. They have special lids or trapdoors to place the sensors. We always fly with 2 types of sensors, with a LiDAR and a digital camera simultaneously. And this year, before that, we bought a UAV by Tero. You saw the results already. And we did some testing, and the results were quite successful. Now we need to introduce a span system, which is manufactured by Novatel. The same system which is installed in large planes, actually. It's done to ensure high quality for our data, to make sure that the accuracy is higher. And this way we will be fully GPS dependent only. We already have planes. What else did we need? because planes only collect data. What comes next? In order to work with photogrammetric projects or topographic projects, we have two lidars manufactured by the same company as the first one. We bought the second one with the same company too. And we use them for different projects. For smaller projects, we use Kyo 480. It can scan at 300 kilohertz frequency and flies a bit lower. And for larger projects, in case of denser foliage, we use Lidar Q 780. It has better capacity in terms of scanning, has more points, especially in the areas with dense foliage. We can have 1 or 2 points per every square meter of the area. Now, about the digital cameras. I mentioned in the very beginning, the very first camera that we bought was 3D Uno. It is like I will tell you a story about it. It was a governmental factory during Soviet Union. That is why its infrastructure processes were clearly defined in terms of that they were mostly manufacturing products for the military, and then they converted themselves to the civil market, and that's what they do now. And there are 3 sensors, which helps us capture a landscape at different angles, 17 and 26 degrees. I cannot say that we can do simultaneous stereoscopic, but it is still triple stereoscopy. We can move forward and backwards, and we can move along different borders of different width. And after that, the operator starts doing the actual cartography along the duration of the whole border. Now we're trying to restore this classic model, photogrammetric models, 50, 60 centimeters perhaps, and now the overlap is about 50-60%. Here to the right, you can see some of the corrections related to the scale, what altitudes we're flying at, and what scale we can ensure, and what pixels we have for each height pixel resolution. We use these cameras for photogrammetric projects, for the cadastral projects, for transport projects, because it is the Ministry of Transport that approaches us for such photogrammetric products, also photos, level curves, and so on. So the second camera that we bought is Uno di Uno. It was specifically developed for joint use with Lidar. Its focal length is adapted to the fact that when we have scanned it with Lidar, we will have the same breadth of the swath breadth, and we have 2 types of data from Lidar in the camera, basically. This camera was fully in-house made. Geosystem manufactured it. And the next camera is camera that we bought, also has same focal length. It helps us work on the same swath size, but it has 2 sensors instead. First camera has only 1 sensor. It works in vertical projection. That's why we can receive vertical images based on points. And the second camera has 2 sensors mounted on it, and we can work in infrared and RGB bands. It's a multispectral camera. Basically, we can survey the landscape and get infrared and RGB results. And the characteristics are quite similar in both cameras.
Смотрят на время. Bueno.
I'm looking at the time. Here, we're trying to explain how our camera works compared to other types. And here, the main difference is that we have to go through the whole area layer by layer, and we'll just have to match those fields together. The exposition is quite high, and the time of triangulation is also quite high. This camera is very similar, and I have a quick example for you. Here we process it by different levels. At the top you can see the first raw image, then we pre-process it or check it and control it with GeoSystem, and the last image is already rectified. Here we use a different software for that. Actually, we can also work with ADS-40 or ADS-80 and format and process or work with any types of images. Here this camera has a big advantage. That's what I wanted to tell you about, relying on our experience, of course. It's just that we have a minimum number of ground control points. This is an example that we did in Aguascalientes. We used a regular camera for that. And as you can see, we have a huge number of ground control points, and to your right you can see the same project but with our camera instead. And you can see right away the differences, how many points we have here. Naturally, the first example implied more manual and field work and more time for processing, and the second option has its own advantages, naturally. Here we can get virtually vertical image because we have a sensor, and we can make a true orthophoto. And as I told you, in 2010 we had an idea to use these two sensors together, and as of 2012 we started to use it in practice. In this way we have a digital camera with vertical sensor, a camera with Lidar, Q480. This is the very first attempt to manufacture a combined system. That is why we do have a minimal number of ground control checkpoints, and that's how we implemented this project. And has been in operation since 2012. Here you can find the characteristics of our LiDAR, characteristics of the camera. If somebody wants to learn more about it, I can tell you more about it. This camera, as you can see, works with 75mm. This is the main advantage in our case for scanning with LiDAR that we work with. And of course, this is the system that we use. It was developed by Novotel company. we have GPS with double frequency mounted on board. Now we already have 3 systems with 3 lidars of the same family. And naturally, we shouldn't forget about how to store the data. For that, we have onboard computer with hard disks that record all these volumes of data that we acquire in 3-4 hours of the flight. 2 different disks with a backup, and each one of them records the results from the camera, another from the lidar. We started using the system in 2012. Now we work with the other lidar, more powerful one, and with the same camera. And the third system, now we're in the process of implementing it. We use same lidar, 480, and the camera with 2 sensors with infrared. So now we have 2 systems in place, and we can get orthophoto based on 9 points. I will quickly describe to you how we do the imaging with our cameras and lidars. First, we need to get permission from INEJA. Here in Mexico, it's a mandatory thing if you don't know. This is an institution which allows us to fly over different areas. Then after that permit, we develop a flight plan based on our software for that. And then we do all the topographic imaging acquisition with LiDAR and with camera. And in some projects, we have control points, ground control points, and after that, we use already piloted craft, and then we use more precise project with 2 levels of control, and sometimes we can achieve 15-centimeter precision in 3 axes X, Y, and Z. Here we calculate the trajectory. After the flight, we calculate the trajectory. This is for that we use special Novotel software who helped us develop our system. This is a point cloud generation and rectification of the point cloud, and naturally we get very good results, quite precise ones, in our photogrammetric projects. Here I will show to you some of the examples of our products based on our LiDAR acquisition. All people know already what point cloud is all about. There are different formats and different curves that we can generate using these products. And speaking about photogrammetry now, or cameras that we use, here we can get, you can see the first image, and the next one is turned into a map and the plans. That's what we needed to get. Also, I'd like to speak about how we generate synthetic stereo pairs. We have only 1 sensor. I told you we don't have a direct stereoscopic function. That is why, based on the point cloud and LiDAR, this is the algorithm that we developed specifically in-house for one of the Chinese manufacturers. In this way, we can make such dense triangulation network. And on this slide, you can see it. We work with the sensor. And after that, we have such a stereoscopic pair. This algorithm allows us to process big volumes of information, more than 2 gigabytes of data. It is a very easy to use algorithm, as far as its use is concerned. And here you can compare the left and right images, and everything becomes clear. I'm just explaining the process now, how we shape up the stereoscopic synthetic pair. Here we get the classical products of orthophoto with planimetry and altimetry. You can see the well-known 3D models and virtual 3D tours. We shoot videos like that, and the plans, because all governmental institutions want to get plans for all their projects, infrastructure projects. Here you can see an example of one of such projects that we prepared for Ministry of Transport, and we then compared the results of this project with the field work and our Lidar image acquisition. And here you can see the columns and the differences that we acquired. At height, the accuracy was less than 5 centimeters. This is Lidar versus field image, field acquisition. And here you can see our designated products that I hinted at earlier. I will just quickly browse the slides. Whoever is interested in them can approach me and can tell you more about them. These are geological surveys with Lidar, biomass surveys, and environmental impact assessment. And here you can see some of the major projects that we implemented for gas pipeline. Quite long lines, actually more than 200 kilometers, with different density of points. And here you can see projects for power lines. Also many points, quite sizable density. And here we can check the evaluation of disaster impact we used for that same system. Here you can see highways and roads, mines. And today I tried to explain. I almost approached the end of my presentation. You can see what we can get with our system when we use combination of Lidar and photogrammetry and the camera. First of all, we can get good quality image of the territory with all its vegetation, which help us to have a synchronous scanning with Lidar in the camera, and you can see it on the image, 2 different flights, and the results are analogous to each other. And eventually, we come up with a positive result, quite quick, automated process, and minimum number of control points on land. Of course, our prices are incomparable to traditional methods, conventional methods, which imply more movements and more interference with the private property and areas.
Also, we work horizontally and vertically. We can expand survey areas. We can work with drainage, and this is a wonderful tool for geographic surveys. On your right, you can see that thanks to this technology, we can see the area under the trees, under the canopy, even though the vegetation can be quite thick. And this can be reached only by combination of Lidar and camera. At the end, I'd like to announce that last year our company was awarded with a prize for the technology that we implemented for the INA Institute. This is a significant achievement, On our website, you can check the award presentation ceremony. Thank you very much. I'm looking forward to your questions unless I ran out of time completely. Thank you very much. This was a wonderful capper to our plenary, I must say. Such a global, informative presentation. Do we have any questions? So the abundance of information, no comment. In fact, since we're greatly behind schedule, and knowing that Elena will be with us throughout the conference days, there may be a lot of questions, and you're not sure which one you should shoot first. Maybe it's camera, maybe it's processing modes. These are mostly global, generic issues that will entail lasting explanations. I have a lot of videos, how we do processing of data. So that's quite interesting. Thank you. So our agenda is used up. Is there anybody wishing to say anything based on our 2-day work? Anything you wish for? Anything you'd like to criticize? Well, in that case, I have a few announcements to make. About tonight, we will have dinner at 7 o'clock. So dinner will be served at Kokotal, a restaurant where we had lunch. At 8:30 p.m. there will be a musical night at Kokamaya's bar. You will hear some music. You can go there. There is a bar where you can listen to music, have a couple of drinks with your pals. We'd like everyone to have a chance to talk and discuss the outcomes of the conference. This is marked as B2 on the map, so you go straight down to the C line, and it's quite lively there. At 10 p.m. there might be karaoke available. Katya will be there at 8:30. If you wish to sing at 10 p.m., you must submit your request, and the song that you would like to sing in Russian and in English. Anyway, you should select a song and inform Katya about your choice. About tomorrow, since we are such a big team, don't forget that the master classes tomorrow start at 10 a.m., lasting till 1 p.m. There will be 2 master classes, one in Russian, the other in English. Here on the premises of the lobby area. So the same area will be separated by partitions. Master classes will be used to showcase photo model features, new developments, if there are people who know the system for a long time. So you can ask all the questions you want. Everyone's invited. Usually they are very popular. Right after the master classes, from 1 to 2, there'll be a lunch break, and then there'll be 2 roundtables. The first roundtable should be of interest in the light of the last session we have had. We'll focus on aerial, spaceborne, and UAV imaging. You know that boundaries of projects overlap a lot, and people who do aerial photography don't like those who do UAVs. Space imaging has gotten very near aerial photography in terms of resolution. So understanding where the boundaries lie and how to choose the best technology should be quite interesting to discuss. So we invited people to moderate with knowledge. So we'll have Amir Valiyev, one of the top experts on UAVs. I hope Yuri Grigorievich Reisman will take part as representative of aerial photography, and Andrei Yurievich will separate the two parties in case of big conflict. And the Airbus representative will tell you all that you must use space. I remember a round table in France. People were talking for 2 hours after the round table closed. From 4 p.m. to 5:30 p.m. There will be a round table on challenges of mapping in the 21st century. Gottfried Konechny will be a moderator. Where is mapping going? 2D, 3D, local or global? Gottfried Konechny is an expert of United Nations, ex-president of the ISBRS, a person who is deeply immersed in this field, so this should be of interest to practitioners. And finally, tomorrow night, we will have a gala dinner. This is the most important event of any conference. It will start at 7 p.m. at Fuentes restaurant. We haven't been there. Very few people have been there. Typically, you have to pay to get there. You can go there by foot, but you'd better use a hotel shuttle. Sorry. Shuttles will pick us up at 6:45 p.m. Please dress properly. Men will wear tuxedos. Ladies will wear long dresses. At the gala, we're going to have a lottery. We will compete for 2 free photomod versions, one in Russian, the other one in English. I think that photomod winners will pay for their participation in the conference several years ahead. Sometimes there was a secondary market for photomod. You win a photomod for 25,000 and sell it for 10,000. So I wish you all good luck and to get your trophy. And the day after tomorrow. Of course, we will meet tomorrow, but the day after tomorrow is a tour day. You all know that we are on the Mayan soil. So we are going to put ourselves into the Mayan civilization. Yesterday we had Mayan dancing, and on Thursday we will see the architecture. We will visit 2 wonderful towns. I guess that about does it for me. Feel free to ask questions. My staff is always around and available, ready to take your questions. Do you have any questions now? I thank you very much for participation. I think it was fun.